Every time you ask a generative AI to write an email, generate a piece of code, or draft a corporate strategy, it feels weightless, doesn't it? It feels completely invisible. But let's dive into this explainer and absolutely shatter that illusion. We're going to see why your seamless new AI tools might actually be a ticking time bomb for your company's net zero ESG targets.
Because here's the wild thing about how this tech works. You hit enter on an AI prompt, and the result appears instantly on your screen like magic. But hundreds of kilometers away, an array of massive cooling fans is screaming, and thousands of liters of fresh water are vaporizing into thin air just to keep those servers running. If your company has a strict net zero target, your shiny new AI initiatives might completely blow up your ESG goals before they even get off the ground.
So let's jump into Section 1, the hidden cost, the reality of the AI diet. To understand the true corporate risk here, we really have to look closely at what these large language models are actually consuming.
Let's start with the power bill. A single generative AI prompt consumes roughly 10 times more electricity than your standard Google keyword search. Think about that for a second. Every single query demands about 0.24 watt-hours. Scale that up across thousands of employees doing this dozens of times a day, and your localized energy demand is going to absolutely skyrocket.
And it's not just power. Because those massive graphic processing units, the GPUs, run so incredibly hot, data centers rely on massive evaporative cooling towers just to keep the servers from melting down. Training just one GPT-3 scale model consumes a staggering 700,000 liters of fresh water. That is literally 2 liters of water evaporating on site for every single kilowatt hour of energy consumed.
Zooming out to the macro scale, the numbers are, frankly, alarming. By 2030, global data center electricity consumption is projected to reach 945 terawatt-hours annually. To put that into perspective, that nearly triples the combined electricity demand of entire nations like Pakistan, Bangladesh, and Nigeria. Now, beyond just the power and the water, we're also dealing with a massive e-waste shadow. The physical hardware lifecycle of AI is unbelievably fast. These AI chips evolve so rapidly that yesterday's cutting-edge hardware becomes completely obsolete in just a few short years. This accelerates a huge unmanaged cycle of corporate electronic waste that sits hidden away beneath the software layer. And you know the old saying, we can't manage what we don't measure. So we've got to track this impact using frameworks like the Software Carbon Intensity, or SCI score. Think of this as a nutritional label for your software. It calculates the overall carbon footprint by combining the runtime energy it uses, the carbon intensity of the local power grid, and the embodied carbon from the physical manufacturing of the hardware itself. On the water side, to track the evaporation happening in those massive cooling towers, IT teams use a metric called Water Usage Effectiveness, or WEU. The historical average for data centers is around 1.8 liters per kilowatt hour, but the ultimate goal for best-in-class AI facilities today is to push this ratio as close to zero as humanly possible to protect local water tables.
All right, on to Section 2, the Indian squeeze, tech ambition versus climate reality. Let's see how all this builds into an urgent operational crisis right here in India's booming tech landscape.
India is absolutely sprinting toward tech dominance. We're seeing massive data center construction booms in major hubs like Mumbai, Chennai, and Bengaluru. But here is the climate collision. Many of these thirsty server farms sit right next to communities that are already suffering from severe seasonal water scarcity and power grid overloads. This places a very real governance and social risk on companies whose cloud providers are actively straining those local public utilities.
Because of this extreme industrial water stress, regulators are stepping in hard. For facilities operating in overexploited groundwater, red zones, implementing strict zero liquid discharge systems is no longer just a fun green PR move. It is a legal survival mandate. Without it, companies are outright denied operating consent and face immediate shutdown orders.
And the financial risks of ignoring this? They're staggering. Under India's carbon credit trading scheme, a blind push into AI without proper decarbonization could completely obliterate your ESG goals. Failing to align with structural decarbonization pathways could trigger up to 3,010 crore rupees in regulatory penalties by 2030 for major industrial players. Literally, your digital transformation could bankrupt your carbon budget.
This brings us to Section 3. Enter Agentic governance, the shield for corporate AI. To stop your AI initiatives from financially and environmentally sinking your company, boards have to deploy a structural shield.
As companies upgrade from simple chatbots to autonomous AI agents that execute complex, multi-step corporate tasks, agentic governance becomes absolutely vital. This means hardwiring efficiency directly into your workflows. Instead of letting an AI agent run a massive, energy-draining large language model query just to do a simple spreadsheet sort, agentic governance forces it to route the task to a smaller, localized model. It proactively restricts that unchecked resource consumption.
The AI Governance Open Framework, or TAGOF, breaks this down brilliantly into functional layers. It starts right at the capability layer, strictly limiting what tools an AI agent can even interact with. Then it moves all the way up through coordination and routing to finally reach the governance layer, which enforces mandatory human-in-the-loop checkpoints and automated kill switches. Basically, it makes sure any complex AI action is bound by strict guardrails, optimizing for both safety and computing efficiency. And treating compute optimization as a mandatory compliance checkpoint is quickly becoming the global standard. New sustainability domains are being baked directly into frameworks to enforce algorithmic audits. For instance, NIST 2026 mandates environmental sustainability committees to track energy footprints, while the Compel version 2.5 framework introduces Domain 19. This forces you to accurately measure compute footprints and audit the emissions of your entire AI supply chain.
Moving on to Section 4, let's open up the Green IT Playbook, an action plan for CIOs and CSOs. We're going to turn all this alarming data and theory into a concrete action plan your management teams can execute today.
Steps 1 and 2 are all about vendor audits and model optimization. First, audit your cloud providers. You have to demand clear, location-specific power and water usage effectiveness data from your vendors so you know exactly where your compute is happening. Step 2, immediately stop using massive frontier models for simple menial text tasks. Adopt localized, slimmer open-source models that use a fraction of the compute power but give you the exact same business results.
Step 3 involves carbon-aware load shifting and advanced cooling. Basically, program your heavy, non-urgent AI data training to run during off-peak hours, specifically when the local grid is heavily fueled by wind and solar power. Also, you've got to push your data centers to transition to advanced liquid cooling techniques and maximize their cycle of concentration to drastically cut down the fresh makeup water they need.
So, the crucial takeaway here is this. Artificial intelligence can absolutely optimize our supply chains and predict climate risks, but only if it doesn't break the environment in the process. True corporate governance means building a tech stack that is as green as it is smart.
Which leaves me with one critical question for you to ask your IT and sustainability directors. Has your company actually calculated the carbon footprint of its digital transformation yet? It's a conversation you need to be having right now. Let's talk about it down in the comments below. Be sure to hit like, subscribe, and forward this explainer to your team so you can start building your green IT playbook today. Thanks for joining us, and keep learning.